Hello, hi everyone. Welcome to the Student the Brand. Today topic is light reflection and refraction. So today we are discussing this topic. In this topic, so we are considering about this one, right? And so reflection of light. So I'm considering the plane mirror. This is the plane mirror. I'm considering the plane mirror. So like this, okay. So plane mirror I'm considering plane mirror. So when the light is incidenting on it, this incident ray, the light which is incidenting on the surface, this incident ray, the light is which is reflecting back, that is reflected ray. So here you can see the light which is reflecting back. So I'm considering like this reflected ray, and the line which is perpendicular to the surface, this is a normal line, this is a normal line. And here if you are extending this one, you are taking, so what is that one? Undeviated line. So undeviated line considering the angle between incident ray and reflect incident ray and and so here it is incident ray, incident ray, and this one I'm considering the reflected ray, reflected ray, and the angle between incident ray and here you see the angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Angle of reflection I'm taking. Okay, so the and this is the initial direction of the incident ray. Whatever I'm taking, this is the initial direction of the incident ray. This one initial direction of the incident ray, and the angle between reflected ray and deviated line is called angle of deviation. Angle of deviation. So now you can see, now you can observe whatever we are considering. So incident ray, this is incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. and the bouncing back of the light from the reflecting surface. So this whole phenomena you can observe, the bouncing back of the light, right, is reflecting back from the surface. So that's why it is called a reflection of light. So reflection of light, this whole phenomena is called a reflection of light. I'm considering the bouncing back of the light from the reflecting surface. This whole phenomenon is called reflection of light. Called reflection of light. Okay. And here, loss of reflection. We have to discuss few more points. One is loss of reflection. There are two laws of reflection. One is angle of incident equal to angle of reflection. Angle of incident is equal to angle of reflection. So angle of incident is equal to angle of reflection. And the second point is incident ray. So this is the incident ray. Incident ray I am taking. This is incident ray. Incident ray and reflected ray and normal line. Incident ray, this incident ray, and reflected ray, this is a reflected ray, and this one is a normal line. This normal line. All are lies on the same plane. Incident ray, reflected ray, normal lies on the same plane. These are the two laws of reflection. Two laws. Two laws of two laws of reflection. So very important here. So we have to understand reflection phenomena. They may ask for 1 mark. Reflection phenomena and the loss of reflection, they last for 1 mark. Loss of reflection, if both the reflection and loss of reflection, they may ask for 2 marks also. 2 marks. And MCQs also very important. Okay, so this is about reflection of light and loss of reflection. And coming to the next one, angle of incidence. Angle of incidence is I, angle of reflection is R, angle of deviation is D. So now we will discuss about angle of deviation. So we'll work out on angle of deviation. Angle of deviation means normally if you see just now we discussed about here I am taking the surface. So I'm considering this the surface. What is the surface? Plane surface. This is the incident ray and this will be the reflected ray. So and I'm considering this a normal line. Whatever we are taking this a normal line. Normal line I'm considering this is the normal line. Here is the normal line. The angle between incident ray. So this incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. And the deviator line. So here is the deviator line. Why I'm drawing means. So here is the point. Very important point. That's why we have to discuss. That's why we are. I'm drawing once again this diagram. Okay. So here, once observe the diagram. Just 1 minute. Observe the diagram. We'll see. No? Now you can observe. So incident ray, reflected ray, normal light. Here is the incident ray. This is the incident ray. This is a reflected ray, and this one is a normal light. Now, so as I said, this angle of incident, right? Angle of deviation, angle of incident, angle of reflection, angle of deviation. So here is the point. The point is, first point, we know angle of incident equal to angle of reflection. Angle of incident is equal to angle of reflection, right? But here, in this one, you can see in this line, this line is a linear pair. This line is 180 degrees, linear pair, 180 degrees. I'm taking because so these three angles, angle of incident, angle of reflection, angle of deviation, all are on the same line. So that's why I'm taking angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. 180 degrees. Now we know angle of incident is equal to angle of reflection, right? Angle of incident equal to angle of reflection. So that's why in the place of angle of incidence, so I'm writing angle of reflection, I'm writing angle of incidence. Even in the place of angle of incident, we can write angle of reflection also. So 180 degrees. Now you can see here. So angle of incident, angle of incident. So angle of deviation equal to 180 minus 2 angle of incidence. We can also write this one angle of deviation equal to 180 minus 2 angle of reflection. 2 angle of reflection. Like this also we can write. Like this also. So that is about angle of deviation. And we can go to the next one. That is about angle of deviation. So next we will go with the types of reflection. Types of reflection. Types of reflection. There are two types of reflections. Types of reflection. First one is regular reflection. Regular reflection. Second one is irregular reflection. Second one is irregular reflection. Irregular reflection. So regular reflection means reflection takes place. Reflection takes place on smooth surface. Reflection takes place on smooth surface. So now we'll talk about regular reflection. Regular reflection. Regular reflection. Okay. So we'll see now. So I'm taking the regular reflection takes place on smooth surface. So I'm taking here. So this one plane surface I'm taking plane. Okay. So plane surface. So incident beam is if you take. So I'm taking the incident beam. Incident beam means I'm taking here this the incident ray, one light ray, and another light ray I'm taking. So this also incident ray. So what happens here? So all light rays, whatever the light rays are incidenting on it, all light rays are parallel to each other. All light rays are parallel to each other like this. Okay. Then reflector light rays also parallel. Whatever I'm taking, reflector light rays also parallel. So like this I'm considering reflector light rays here also. So incident light rays are parallel, reflector light rays also parallel to each other. Then this type of reflection is called regular reflection. Whereas irregular reflection, if you take irregular reflection, irregular reflection, so it will be rough surface. It will be rough surface like this. I'm taking like this. Okay. So incident beam is parallel. So whatever the light rays I'm taking, so incident beam is parallel like this. Incident beam is parallel. But reflected beam is not parallel. So reflected light rays will move in different directions. So in different direction, the reflected light rays will move. So here like this. So this type of reflection is called irregular reflection. Irregular reflection. Irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface, but irregular reflection takes place on rough surface. So here you can see this is the regular reflection. Regular reflection, the surface is smooth surface, smooth surface. Whereas irregular reflection, you see, this is the rough surface, the surface, rough surface. Okay, okay, done. Next one will go with the object and image. So I'm considering the plane mirror like this. This is a plane mirror. I'm taking the plane mirror. Okay. So here is the normal line. I'm considering this is a object. This is a object. There is a real object. From here, light rays are coming like this. One light ray I'm taking here, and one another light ray I'm taking like this. After refraction, the light rays are moving away from it. Here also away from it. So if you are extending, those light rays are meeting at one point on the normal line. Okay, principal axis. You can see. So here is real object. This is the virtual image. This is a real object. This is a virtual image. Real object and virtual image. Here you have to understand. Here is the object. I am taking the object is here, and here it is image. Image. So object is real. Image is virtual. Object is real. Image is virtual. Whereas object is virtual. Image is real. Image is real. So once observe these 2 points. If object is real, image is virtual. If object is Virtual, image is real. Object is real, image is virtual. How this will happens? Now we'll see. When you take here, here you can observe now in this case, first case I am taking this a case 1, this a case 1, and coming to case 2 I am taking this a case 2, in the case 2, so we are extending, so I am taking light rays are coming from certain point. So here you have to understand, this is a plane mirror, one side is reflecting surface, another side is coated. Here also same thing. So one side is reflecting, another one is coated like this. Okay. Now light rays are coming from like this, and here also I'm like this. Those light rays are after reflecting, those light rays will meet at one point here like this. If you are extending these light rays, so reflector light rays, those light rays are meeting at one point. Here you have to understand very clearly, this is the real image, this is a virtual object. Here is the real image and here is the virtual object. So these are the incident light rays, these are also incident light rays. Light rays are coming from infinity, after reflection light rays will meet at one point. So this is the real image. Here also real image. And here the extension of incident light rays are meeting at one point. That's why it is called virtual object. We are extending the incident light rays, right? That's why that is virtual object. So here you have to understand. So this is the real object and virtual image. So here object is real, image is virtual. Object is real, image is virtual. Whereas the second case you observe, the second case, real image is real, object is virtual. Same thing here. Same thing here itself. Object is virtual, image is real. So I hope you got it. So that is about object and image. Next one will go with the plane mirror. Plane mirror. Plane mirror. Plane mirror. So plane mirror, if you see, if I'm considering the plane mirror like this, okay, one side is reflecting surface, so object I'm placing here, object I'm placing here like this. One light ray I'm taking. How many light rays are required to form the image of the object? Minimum 2 light rays, right? So another light ray it is intersecting, so you can see, so it will be reflected back, and here one more light ray I'm taking here from here, so that will be reflected back. So if it is passing along this line, it will be, so if you're extending all these light rays, so here if you extend this one and if you extend this one here, so the image will form here. Virtual image will form. Virtual image will form. So here height of the object is there. That is nothing but A, B, and here height of the image A dash, B dash, A dash and B dash. Object is real. First point is here you can observe in this case AB. Object distance is equal to, so from object, this is the object and this is the mirror and this is the image. I am considering this distance, that is object distance U, and this distance is called image distance B. In this case, object distance is equal to image distance. Second one, height of the object. This is the height of the object, HUO, is equal to height of the image. Height of the object is equal to height of the image. And third one, it also shows lateral inversion. What is lateral inversion? The phenomena of converting of left side of the object appears to be right side of the image, and the right side of the object appears to be left side of the image. This mirror conversion, this mirror image is called lateral inversion. Lateral inversion. Lateral inversion. Lateral inversion. So I hope it is, you got it. So that is about lateral inversion. Clear? Next one. So until now it is clear. Next topic we'll discuss in the next video class. So next live class. So thank you so much.